Hello everyone, this is Chinnaiah Kalpana here. In this video, we're going to solve a differential equation using variation of parameters method. So let's get going. Problem: solve y double dash minus 2y dash plus 2y equal to e power x tan x, or y d square minus 2d plus 2 into y equal to e power x tan x using variation of parameters method. So we are given a differential equation of order 2. Given differential equation, y double dash minus 2y dash plus 2y equal to e power x tan x, considered as equation number 1. We can write y double dash as d square y by dx square minus 2 into write y dash as dy by dx plus 2y equal to e power x tan x, right? We can write d square y by dx square as capital D square y. Here d is a differential operator. Minus 2 into write dy by dx as capital Dy plus 2y equal to e power x tan x. Now take y common from all the terms of LHS. We'll get d square minus 2d plus 2 into y equal to e power x tan x. Which is our equation 2. Equation 1 in operator form is our equation 2, which is in operator form. Say f of d into y equal to some function of x, where f of d is d square minus 2d plus 2 and r of x is e power x tan x. Let's now write the homogeneous equation of equation 2. The homogeneous equation of 2 is d square minus 2d plus 2 into y equal to 0, considered as equation number 3. Now we need to find solution to this equation using the auxiliary equation, and later using the homogeneous equation, that is the solution to homogeneous equation, we'll find the general solution of 1 and 2. Now coming to the auxiliary equation, the auxiliary equation is f of m equal to 0, where f of m equal to, we have f of d square minus 2d plus 2, right? Let's replace the differential operator d by m, so that we'll get f of m equal to m square minus 2m plus 2. Then the auxiliary equation becomes m square minus 2m plus 2 equal to 0. Now we need to find roots to this equation. So here we are going to use quadratic formula minus b plus or minus square root of b square minus 4ac by 2a. In order to find the values of a, b, c, we'll just compare this equation with am square plus bm plus c equal to 0, a quadratic equation in m. By comparing these two, we'll get a equal to 1, b equal to minus 2, c equal to 2. Now apply the values here, just substitute the values. Minus of minus 2 plus or minus square root of minus 2 whole square minus 4 into 1 into 2 by 2a, which gives us 2 plus or minus square root of minus 2 whole square is 4, minus 4 2s are 8 by 2. We can just, we'll get 4 minus 8 is minus 4 by 2. Now write square root of minus 4 as square root of minus 1 into 4. Now split the square root as square root of minus 1 into square root of 4 by 2. Since we know that square root of minus 1 is I and square root of 4 is 2, so you'll get 2 plus or minus I into 2 by 2. Now take 2 common from the numerator, you'll get 2 times 1 plus or minus I by 2. Where 2 gets cancelled, you'll get 1 plus or minus I. Therefore, m equal to 1 plus or minus I, a pair of complex conjugate roots. The roots are complex conjugate. Right? We know that when two roots are complex conjugates, say a plus or minus ib, Then the solution to the homogeneous equation looks like y equal to e power ax into one constant into cos bx plus another constant into sin bx. Here we are taking C3 and C4 instead of C1 and C2 because we want C1 and C2 to appear in the last general solution. Now coming to the solution to our homogeneous equation. The solution to homogeneous equation is y equal to e power 1 into x of C3 cos bx plus C4 sin bx, which gives us e power x of C3 cos x plus C4 sin x, or C3 e power x cos x plus C4 e power x sin x. Therefore, y equal to C3 e power x cos x plus C4 e power x sin x is the solution to homogeneous equation. Let y equal to, just replace the constant C3, C4 or parameters with functions of x, a and b. We'll get a e power x cos x plus b e power x sin x, be the general solution of 1 and 2. Where a and b are functions of x. Now we can compare the homogeneous solution with y equal to C3u plus C4v, or this with y equal to au plus bv. We'll just get b, u and b, okay, where u is e power x cos x and v is e power x sin x. U is e power x cos x and v is e power x sin x. And we'll find AB using the formula. A is given, or we'll get A using the formula A dash equals to minus V into R of x by UV1 minus VU1, and V dash is given by U into R of x by UV1 minus VU1. If you notice, we are having UV1 minus VU1 in both the formulas, so we'll begin with UV1 minus VU1, and later we'll find A dash A, B dash B, and finally we'll put A and B in this to find or to get the general solution. Okay. We'll begin with UV1 minus V1. V1 is nothing but V dash and U1 is nothing but U dash, which is nothing but derivative of V with respect to x, derivative of U with respect to x. U is e power x cos x into derivative of e power x sin x minus e power x sin x into derivative of e power x cos x, right? Here we have to apply UV whole dash formula, since we are having two functions and we need to find the derivative of two functions, derivative product of two functions, we can say. This gives us derivative of e power x into sin x plus e power x into derivative of sin x with respect to x minus e power x sin x into derivative of e power x with respect to x into cos x plus e power x into derivative of cos x with respect to x, which gives us e power x cos x into derivative of e power x with respect to x is e power x sin x plus e power x into derivative of sin x with respect to x is cos x minus e power x sin x into derivative of e power x with respect to x is e power x into cos x plus e power x into derivative of cos x with respect to x is minus sin x, which gives us e power x into e power x, right? Just e power x into e power x, or e power x into e power x can be written as e power x plus x, which gives us e power 2x. So just write e power x into e power x, e power 2x for our convenience, into sin x cos x plus e power x into e power x, e power 2x cos x into cos x, cos square x minus e power x into e power x, e power 2x sin x cos x minus into plus minus, minus into minus plus e power x into e power x, e power 2x sin x into sin x, sin square x. So here plus e power 2x sin x cos x minus e power 2x sin x cos x gets cancelled, and you'll get e power 2x cos square x plus e power 2x sin square x. Now take e power 2x common from the two terms, or just write the terms as e power 2x sin square x plus e power 2x cos square x. Now take e power 2x common, we'll get e power 2x times sin square x plus cos square x. Since we know that sin square theta plus cos square theta equal to 1, so we can apply it here, which gives us e power 2x. Therefore, uv1 minus vu1 equal to e power 2x. Now coming to a dash. A dash is given by minus v into r of x by uv1 minus vu1. Substitute the values, minus v e power x sin x into r of x e power x tan x by uv1 minus vu1 is e power 2x, which gives us minus e power x into e power x is e power 2x sin x into tan x by e power 2x, where e power 2x gets cancelled, and this equals to minus sin x tan x, since tan theta equal to sin theta by cos theta. So just replace it, replace tan x with sin x by cos x, which gives us minus sin x into sin x is sin square x by cos x, since sin square theta plus cos square theta equal to 1. From this we'll get sin square theta equal to 1 minus cos square theta. Just replace sin square x now. Replace sin square x with 1 minus cos square x by cos x, which gives us minus 1 plus cos square x by cos x. We are having two terms in the numerator and one term in the denominator, so we can split the total expression into two terms. We'll get minus 1 by cos x plus cos square x by cos x. Since we know that reciprocal of cos theta is secant theta, so we'll get minus secant x, plus if 1 cos x gets cancelled, we'll get plus cos x. Therefore, a dash equals to minus secant x plus cos x. We got a dash. Let's now find a using this a dash. A dash is nothing but derivative of a with respect to x. Now let's separate the variables by taking the differential dx to RHS. We'll get dA equal to minus secant x plus cos x into dx, or dA equal to minus secant x dx plus cos x dx. Here the variables are separable. We can apply or perform integration. Since we know that integral secant theta d theta equal to log mod secant theta plus tan theta and integral cos theta is sin theta. So the above equation becomes integral dA equal to minus integral secant theta, secant x dx is log mod secant x plus tan x plus integral cos x dx is sin x plus some integral constant, say c1, or a equal to minus log of secant x plus tan x plus sin x plus c1. Therefore a equal to minus log of secant x plus tan x plus sin x plus c1. We got A. Let's now find B dash and B. Coming to B dash is given by u into r of x by uv1 minus v1. The u is e power x cos x and r of x is e power x tan x by uv1 minus v1 is e power 2x. E power x into e power x is e power 2x into cos x tan x by e power 2x, where e power 2x gets cancelled, is equals to cos x into tan x. Since tan theta can be written as sin theta by cos theta, so just replace tan x here with sin x by cos x, where cos x gets cancelled, and you'll get B dash equals to sin x. Right? Let's now find derivative of, let's find B using B dash. We have B dash equals to sin x, right? B dash is nothing but derivative of B with respect to x. Now just separate the variables by taking differential dx to RHS. We'll get dB equal to sin x dx, where the variables are separable. So we can perform integration. Integral dB equal to integral sin x dx. From this we'll get B equal to integral sin x is minus cos x plus integral constant is c2. Therefore B equal to minus cos x plus c2. We got A and B. Let's find the general solution. Therefore the general solution is given by y equal to a e power x cos x plus b e power x sin x. Substitute a and b here. A is log of secant x plus tan x plus sin x plus c1 into e power x cos x plus b minus cos x plus c2 into e power x sin x, which gives us minus e power x cos x into log of secant x plus tan x plus e power x sin x cos x plus c1 e power x cos x plus into minus minus e power x sin x cos x plus c2 e power x sin x. So here minus e power x sin x cos x and plus e power x sin x cos x gets cancelled, and we'll get minus e power x cos x log of secant x plus tan x plus c1 e power x cos x plus c2 e power x cos x. which gives us minus e power x cos x into log of secant x plus tan x. Take e power x common from the last two terms, we'll get e power x times c1 cos x plus c2 sin x. It's sin x, okay? Or we can write this as e power x as c1 e power x of c1 cos x plus c2 sin x minus e power x cos x log of secant x plus tan x, which completes the problem. So we have seen a problem from variation of parameters method in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.